So guys, very good evening everyone. And today is the last class of our C programming language classes. So in today's class, we'll discuss about two topics. One is command line arguments, and second one is binary files. So first of all, I'll explain you how you can work with command line arguments. Open the code blocks ID. It will take some fraction of seconds of time to open the code blocks ID. Once the ID is open, then I'll show you that how you can write programs using command line arguments concept. So I'll open this file. Here you can see 8 to 9 p.m. batch. Okay. And now just see what is the program name I have given. Here the name of the program is test. The name of the program is test. And I'll write one statement here, printf hello world. Okay, and I'll just keep semicolon. I'll run this program. It'll print this message on the screen, hello world, you can have a look. Now what I'll do is, I'll run this program from the command prompt. Means you go to the place where this file is stored. This file is stored in E drive 8 to 9 p.m. batch folder. So I'll move to this E drive. I'll move to this E drive. Okay, and you can see 8 to 9 batch p.m. So here the file is stored. Now in the address bar, you just type cmd. That's nothing but this particular folder will be opened in command line interface. Now here you can say simply test, and your C program will run and it will display the output. Now, suppose if you want to pass input to the program itself while running this program from the command prompt, then what we can do is, while executing this program from the command prompt, means from here, from this location, you can say test, and you can pass any kind of parameter. Parameter is nothing but it can be any like a constant value. It may be a numeric constant or it may be a string constant. Like I'll say hello and then I'll say welcome. So this is nothing but passing arguments to your main function. So whenever you run this program, what happens, these arguments will be passed to the main function, but these arguments are not received by your main function. These arguments are not received by your main function. So observe, I'll show you the concept that how these arguments which you have passed from the command prompt will be received there. So what you have done is, you have done like test is the file name, and you have passed one argument like hello, another argument is like welcome. So this is your C program what you have written, just imagine, which has main function, and you have some statements here. So the name of this file is actually test.c, but when you compile, it will produce test.exe. It will produce test.exe. So here now what's happening, these arguments are passed to test, and the argument what you are passing to test, they will be received inside the main. But your main is not ready to receive those parameters. Now I'll show you how you can make your main function to get ready those parameters. So here the main function takes two parameters, integer argc. It stands for argument count. Next, character star argv. This is known as argument value, argv. So argc will maintain the number of parameters what you are passing from the command prompt. It will maintain the count. But whereas argv will maintain the values what you are passing actually. Okay. So now see here, I'll say printf number of arguments are. So what I'm doing is I'm just displaying that arguments. So I'll say percentage D comma ARGC. Okay. Now you simply build this program once here. You can say build, then executable file will be created. Don't run it. Go to command prompt. Now you can say test followed by welcome and then hello and welcome. Then you will see like number of arguments are, it's saying 3. See here, it's saying 3. What I'll do is I'll keep this hello world in the next line. Okay, and again I'll rebuild this. Okay, now you can see it's saying number of arguments are 3. So your test, the file name is considered as first argument, hello is considered as second argument, welcome is considered as third argument, test is stored at 0th index, hello is stored at first index, welcome is stored at second index. So if you want to print those values, then here what you can do is you can simply say printf percentage s comma argv of 1. 1 means is nothing but the second argument and 2 is nothing but the third argument. Like this you can print it. So what you can do is you can say build, and now you can remove this hello world statement that's not required. Okay, so you can say build and go to command prompt and run it. So it will tell you there are totally 3 arguments. One is hello, second one is welcome, and the 0th index. In 0th index, you have the file name, the test. So suppose if you are passing like more number of arguments, then it's better. You can make use of for loop. So I'll declare one index variable I, and I'll say here for I equals to 0, I is less than argc, and then I'll say I plus plus. Now what you can do is you can print that /n percentage s comma argv of I. That's it, guys. Again, you compile this program, say build, go to command prompt and run it. See, there are 3 arguments. First is your file name, second one is hello, and third one is welcome. So you may ask me, like, what is the use of this combined line arguments topic and why you need to work with this? So the use of command line arguments topic is whenever you run the program and based upon your input, the program should take some action. See, till now we have seen how to pass input after executing the program, but now I'm explaining how you can pass at the time of executing the program. Means these kind of requirements will come into picture, that whenever you're running a program, then at the time of execution, if you want to tell that this program you want to run it on this particular operating system and you want to allocate this much of memory, then at the time of execution you can pass inputs, you can pass parameters to the main program through command line arguments concept. Okay, so this is what the requirement of command line arguments is. And now I'll show you how we can work with binary files, one of the very important topic, binary files concept. So I'll open one file. So here, let me open this E drive, and here 8 to 9 p.m. batch. So here I'll open just one program. Okay, say for example, vowels program, and in that vowels program I'll write. Actually, I have written one program like how to store information about a student using structures concept. You can just have a look. So this one, I will convert this particular program into binary files. So what I'll do is I'll say save as, and I'll say student store. The file name what I have given is like student store. I want to store information about a student. For storing information about a student, you have to take one structure variable. Okay, so I'll declare one structure inside the main function. Just have a look. This is the structure, and I'll take only one variable for this structure, that is s. So in the variable s, I'm going to read information about one student. In the variable s, I'm going to read information about one student. And here, what I'll do is, I'll read information from the user. I'll read information about this particular student from the user, and then I will store that particular student information permanently into a file. Okay, so this is what the binary files, the last topic of our course. So let me read the data here. I'll say printf, enter roll number, scanf, percentage d, comma ampersand of s dot roll number. And then I'll say printf, enter name, scanf, percentage s, and you can say ampersand of s dot name. And then I can say enter average. Okay, and then you can say scanf, percentage s, comma ampersand of s dot avg. Sorry, average we have taken in float. So let me use f. You are reading one student information from the user. You can have a look. Simple program. This is the structure what I have defined. This is the structure variable. I am reading data. Here, percentage d, ampersand of s dot roll number, s name, f average. Whatever the student data I'm reading, this particular student data, I want to store it permanently into a file. And for that purpose, you have to create a file first. File star fp. So fp is the file pointer I have declared. Now I'll open the file by using a function called fopen, and I'll say the file name as emp.dat. Any file name you can give of your choice. And here you can say AB. A means append, B means it is a binary file. A means append, B it's a binary file. So after reading the data of one student, what you can do is you can write this particular data onto the file directly. And for storing data from RAM memory into hard disk, there is a function called fwrite. You can say ampersand of s, that's the thing, but write from the base address of s variable. It's totally how many bytes we don't know. So I'll use a sizeof function. That many number of bytes one time should be written onto the file. Okay, and here I can say printf record saved. I'll just put a message. So this is the first time we are executing this program. Just have a look. I'll say run. It will ask you 101, Raj, average 99, and you'll get a message like record saved. Now again you can run this program. 102, Hari, and 98 I'll say. It says record is saved. So if you want to know where this data is stored, then you can see in this 8 to 9 p.m. batch folder, I've created a file with the name emp just now today. You can see 21st is the date. You open it, but you cannot read anything because this is a binary file. And I said clearly that binary files are non-readable files. Binary files are non-readable. Once you store the data in a file, then you cannot read the contents of that file. So if you want to read that what is there in this particular emp.dat file, Then for that purpose, what you have to do is you have to write one more program for reading data from this file. So what I'll do is I'll say file, save as, and here I'll say student read. So you have to take the same structure as it is. This time, don't open the file in append mode, open the file in read mode because you are reading data from the file. Okay. And we don't know how many records are there in that file. So what you have to do is you have to use while loop for reading data from that emp.dat file. So here you can say while, okay, and you can say f read ampersand of s comma size of s 1 comma fp. That's nothing but from the file pointer you want to read one record based upon the size and store it into the variable s. And how many times you have to keep on reading? I want to keep on reading this particular data till the fread function returns true. So I can say equal to 1. And here I can say printf slash n percentage d hyphen percentage s hyphen percentage f. In the place of first percentage d, I want to print the value of roll number, second s dot name, third s dot average. Now run this program. It's showing an error. Let me check. Let me put one bracket here. F read is the function, and I'm saying ampersand as of size of s 1 comma fp. Let me check where the problem is. So it's saying that S is in something which is not structure or a union. So I'll just change the while loop syntax. I'll say while one. While one is nothing but while true. And here I'll use a simple fread function to check whether I'm able to read it or not. Let me check the syntax once. I'll just open Google. Fread function syntax in C language. This program already I have written once. So there may be some problem in the syntax. So I'll just check the syntax that how I have written this. Print of percentage D is for roll number, percentage S is for name, and percentage F is for average. And here I'll say S dot roll number, comma, S dot name, comma, S dot average. Put semicolon. Yeah. So that there may be some problem actually in my like printf statement. So I'll give slash n, and you can see here there are two records we have inputted, and both the records are displayed as it is on the screen. So this is actually we call binary files. Once you are good at binary files, then by using this particular concept, you can develop projects in C language. So what I have done is I have created a project. I have created a project. Uh, I have given access to that particular project with the detailed explanation in my video recorded series. You can see here. In this, you go to C programming language courses. C programming language courses here. C programming language classes. And in this, some 19th module is there. 19th module is about a project using binary files concept. At last, 19th module is there. See, this is like 18th is like binary files, which I've explained you just now. And 19th is like the complete student information management system project. So this is about the binary files concept, guys. And this is what the end of today's session. Hope you understood the concept. But remember, if you have missed few classes in the middle, then don't worry. From next month, I will be starting our weekly mastermind session, so that every Friday, 8 to 9, I'll come live on Zoom, and I'll clarify all the doubts, whatever you are practicing. And there is no time limit on that. There is no time limit on that. As these are live classes, so we have like a 30 days duration session. But from next month onwards, we don't have any limitation. So the only thing what you have to do is you have to log in into the LMS, and you have to keep on practicing each and every program which I have explained you there. Hope you got clarity there. Thank you so much.